I want to talk about solving logarithmic equations. So what we end up knowing is that if we have the log of something is equal to the log of something else, so like suppose that I have the log base 2 of x minus 3 is equal to the log base 2 of 5. Well, since they have the same base, that means that the insides have to be equal. So x minus 3 has to equal 5. When you add 3 to both sides, yeah, x is equal to 8. The reason this is the case is because if I take 2 raised to the log base 2 of 5, it actually undoes it. If I take 2 and raise it to the log base 2 of x minus 3, think about what that means. The log base 2 of x minus 3, actually let's kind of do it with the other side. 2 to the log base 2 of 5. And it will happen for the same thing for here. The log base 2 of 5 is the power that 2 goes to make 5. Now take 2 to that power. But 2 goes to that power to make 5, so if 2 goes to that power, then it's going to make 5. Essentially what it does is it gets rid of the log. Same thing here. Log base 2 of x minus 3 is the power that 2 goes to make x minus 3. Now take 2 to that power, so you're going to get x minus 3. So when you're doing a logarithmic equation, you can actually get rid of the logs and leave just the inside and solve it out. And that's essentially how this works. So for that reason, if you have a logarithmic equation, you can go ahead and solve it. I want to show you some of the types of logarithmic equations that we would expect you to be able to solve. So maybe we can solve log base 3 of 1 minus 2x equal to log base 3 of 2 minus 3x. So you take these as the exponents on 3, and you're left with 1 minus 2x is equal to 2 minus 3x. Add 3x to both sides, and subtract 1 on both sides, and you get x is equal to 1. So only one thing you want to be careful about, plug it back in and see if it works. You're going to get 1 minus 2 is negative 1. You cannot plug a negative into a logarithm. So this actually doesn't work. So check that it actually fits in the domain. So since it doesn't fit, it's no solution. So this is one type of equation you might solve. That one's pretty straightforward. You just drop the logarithms and you work with what's on the inside. The other type of equation is when you have a little bit more going on. So suppose that you have something like log base 3 of 2x plus 1 minus 3 equal to negative log base 3 of x minus 1. What you can do for this one is, because you have it as negative 3 right there, you can add the log base 3 of x plus 1 to both sides. And then add 3 to both sides. And you're going to get log base 3 of 2x plus 1 plus log base 3. You can move all the log stuff to the one side is equal to 3. Now write this as one logarithm using the properties. Log base 3 of 2x plus 1 times x minus 1 is equal to 3. Now write these as the exponent on 3, because the base is 3, so you use the base as 3. That cancels that out over here, and you're left with 2x plus 1 times x minus 1 is equal to 3 to the third. So what you end up getting now is you get 2x squared minus 2x plus x minus 1 is equal to 27. So you get 2x squared minus x minus 28 is equal to 0. And now you just have a quadratic that you have to solve. Of course, quadratic is not as enjoyable as you might hope, but you can check and see if it solves out. And what you end up getting is you get x is equal to 1 plus or minus the square root of b squared minus 4ac. So plus 8 times 28 is 160, 224, all over 2a, which is equal to 1 plus or minus square root of 225 all over 4, which is equal to 1 plus or minus 15 all over 4. So x is equal to 1 plus 15 is 16 over 4, which is 4, and x is equal to 1 minus 15, which is negative 14 over 4. Look back at the original equation. The original equation had log base 3 of 2x plus 1 minus 3 is equal to log base 3, negative log base 3 of x minus 1. If I plug in the 4, I get 8 plus 1 is 9, 4 minus 1 is 3. Those are both positive, they're both in the domain. But if I plug in the negative 14 fourths times 2 is negative 14 halves plus 1 is negative, so that's going to be a domain, that's a domain issue. So my real only answer is x equal to 4. And then I keep on playing that game. As soon as I get a logarithm equal to something, I can use the fact that I can take that as an exponent on whatever the base is, and then I can actually solve it out.